think of different applications which are being developed, which will we will use the data that trying to collect from the sensors. So these are endpoint devices which are sensors, wireless sensor network, and you can actually collect different kinds of information, maybe the temperature, maybe the humidity, maybe the what do you call the airflow, water flow, and a variety of sensor perceptions. In fact, you can also look at health things, right? Like your body area networks, you can have W bands, wireless body area networks. People talk about. You would have heard about it. So you can have devices which are embedded on your body, and those readings can be transmitted. So they are all sensors here. So in fact, if you ask me where Internet of Things has come in, it has actually come in from what you call improvements over the wireless sensor networks, the mobile ad hoc networks, the managed kind of things, and slowly we are moving into these things. So the underlying architecture kind of is the sensors, and but you're not connecting the sensors as a network among themselves, but you're connecting it back to a base station, right? Or a what do you call or the internet, and from there it goes to the other side where the data collected can be analyzed and evaluated, right? So these are sensors at the lowest level. Then you have what are called the edge layer, where you have the various connecting devices, maybe an Alexa kind of a thing, or edge layer, and then your laptop or these things which can read that information, and then whatever data is stored here can be evaluated by various applications which are running on top of it. Right? Maybe an agriculture application, maybe a robotics application, maybe a healthcare application. They all can read the data from these devices through the network. So this is what is internet, and these are what are things. So that is what you look at, right? So before internet, it was before IoT, it was all a local area network you could look at. But after that, it becomes that the whole world is connected by a variety of devices. Earlier, if you look at the old mainframe, maybe one single computer, 1,000 people were using it. They were connected by the sorry, is the voice breaking? I think I am on the college internet, should not be an issue. But let me check. Maybe the distance in the mic. Yeah, let me check. Okay, so earlier in the mainframe computer, if you remember, it would be like what you call a one computer, one powerful computer would be surrounded by all the users. They would be connected by a local area network, right? And then all the users of the mainframe would get a terminal on their own system, and they would work on the single system. But now the whole scenario has changed. One computer used by 1,000 people is moved turned the other way around. What is happening? One user is now surrounded by surrounded by many devices. Maybe I can't say 1,000 devices, but surrounded by multiple devices. At least we all carry two mobile phones, or at least two SIMs, maybe one laptop, maybe one tablet. Variety of devices are there. You will sit near a computer, some sensors are there around you. So they are all computing devices, they are all things. So that's how the world has moved on to. And then it is even moving further. So now it is connecting to a variety of devices. Your air conditioner can be connected, your lamps, everything. I'm just talking about the hotel where the lights were getting switched on and switched off, your microwave, your television, your desktop computer, your fridge, your home locking system. You will not actually lock the doors anymore with a key. You will all have digital locks. In fact, some of the hotels I have seen, it is a digital lock. They give you a small card, and then you just swipe the card, and the door is open. So you don't carry a key anymore, and there is no locking mechanism there. The door gets automatically locked. It's a sensor based locking mechanism. And then you have gaming systems. You have different kinds of devices, your sound system, your washing machine, the bus that you are traveling, or your school bus, everything. So you have Internet of Things, Internet of Vehicles, Web of Things, Internet of Robotic Things, Internet of Healthcare Things, and so on. So earlier it was now it is moved to Internet of Everything, combining processes, things, people, and data. So all of them are connected. So this becomes, it's called Internet of Things as we move to the future, everything will be connected. So earlier it was more of a technology and application centric. The applications were all built for the technology. So there were a lot of innovators, customers, vendors, consultants, and then information technology, IT professionals, the integrators in the society, all were together. So it was more, and the center point was technology. But now it becomes more of a user centric. The user at the center, and all are coming around him. So the learning, the mobility, energy, public services. Earlier you used to stand in a line and buy a train ticket or a bus ticket. Now you do your online booking. Everything is on a small app. You used to carry a ticket. You used to take a printout of a ticket, and there were problems earlier. You should have either your hard copy ticket, otherwise they will not allow you. Now a small SMS you can show, and then you can get in to a bus or a train, and there is no problem. So all these things, as you see, the retail systems, when you come out, there will be a time when you go to a supermarket, and then as you are picking up things and putting into your basket, the billing is done, right? So you don't have to actually stand in a line where somebody actually scans through. Now of course it is even saving time, and because they are scanning fast and they are sending you out. But just imagine a time where you go to a Reliance market and then just walk through, and then as you, because you are given a what is called the trolley, and then once you are selected to pick up the trolley, because while you are walking in, your face has been scanned and you have been recognized, because they already know the customers. They have a customer database, and as you are allocated a trolley, the trolley and you are linked. So whatever you put in the trolley gets automatically calculated, because when you're taking out of the rack, because they've already detected you, and they know that the trolley is there, it comes into the trolley gets billed. It's like your what do you call it, the cart application. You go online and you keep selecting the things as they are put into the cart. The cart gets totaled up, and then once you view the cart, it shows you a bill of what things that you have picked up. Then you come, actually you don't have to make a payment, because they already know they know your identity, they know your bank account, and it gets deducted, and you walk out. No billing is done. No bill comes home or by email, or you can have a online soft copy of it on your application, which you have registered with that society, so registered with that shopping mall, right? So wonderful. Just imagine the amount of time we save, right? And then maybe next time when you when you go, you can have a ready-made thing which is already made, because they know the common things that you actually buy. So and already a suggested a basket is already there. Maybe you book your time slot for that I'm coming to the mall, so they will give you a ready-made basket with, sir, these are the normal things that you buy, so the basket is ready. Then you can take anything extra that you want, you can quickly make it. So just imagine if such kind of a facility is given, what a joy it is. So it is going to be human centric applications, right? So what are the characteristics of this Internet of Things? As we look at, the connectivity is the major thing. Like cloud computing needs internet. If internet is not there, cloud won't work. If internet is not there, IoT won't work, right? Earlier wireless sensor networks would work because it was a small network in a geographical region, and all those sensors were at a physical proximity. Now the sensors are anywhere else, and you can get the reading sitting in your office, right? So if the bus is somewhere else, but it is coming. But because you are connected to the internet, you know where the bus is. You know how far you are. Recently, some a friend of mine was coming from another city. He was traveling by his own vehicle, and I was trying to guide him. So I told him I will be standing at a point. From there, I will meet you, and then we. So I sent my location. He sent his location. We were observing how we are closing, and then one came. I realized that okay, he has now come to that. So he got down from his vehicle, got into my car, and then we came home. So that's a kind of a mechanism as we look at if internet was not there, you don't know where they are. But internet is connecting multiple networks. So that is where it is becoming Internet of Things. Earlier it was only sensors, wireless sensor networks, but now it is a network of networks which are connecting a variety of things. So anything can be made to a thing. Now, what is a thing, if you ask me? So, thing is something I would say which can respond to a digital information, right? A response, if it can generate, maybe a simple barcode, right? Anything can be made a digital response thing if I can put a simple barcode on that, right? A book is there, there is a barcode. You put a chair can be made a thing if you put a barcode on that. So when you put a bar scan reader light on that, it responds. It gives you some information. So there is a communication between the chair and something else. Of course, more meaningful things are like microwaves, refrigerators, washing machines. They can be programmed from your mobile phone. Right, you are sitting in the office, you put the clothes at some time, and then you want to start it at 11 o'clock because your maid comes at 2 o'clock and she can write. So you want the washing machine to start at 11 o'clock instead of before leaving the office, switching off the washing machine. So you can exactly set your time, and in fact, you can set it in your mobile phone and leave it. The alarm comes, and then it activates the washing machine. The washing machine starts running, and by 12:30, your clothes are ready to be dried. Your maid comes and dries it up. So that kind of a thing you can think about. So, but every device has to be identified, and there must be some intelligence in that device. The number of devices are going to be huge because it's internet. You don't have to restrict. It can go on for as many number of devices as possible. So you have to be scalable. And because the devices are not on a single network, they are on a distributed networks. So you will have to look at distributed computing, many dynamic operations, and all the devices may not be from the same make, a heterogeneous environment. And all the devices are wireless. They are not wired. They are not powered. They are mostly battery operated, and hence there is a resource constraint. So energy efficiency becomes a very important aspect. We want to save as much energy as possible. And then low power protocols. So the whole perspective becomes that you will look at low power protocols, because I was talking about 6LoWPAN. 6LoWPAN is a low power protocol, lossy, lossless, as far as possible, make it as lossless as possible, right? So that they are low powered, right? So the whole protocol is designed in such a way that it doesn't take much of the electricity and the power that is consumed. So these are the characteristics. So a simple architecture, if you look at, this is how it looks like. These are the things. And if you look at the three diagrams, they are explained in below. The sensor and actuator, there are a processing, and then is communication. So the communication is the internet, and the sensor and actuators are the things. So this is the simple diagram that you look at. So there is a local network to which you are connected. This is what, and then you are connected to the internet. So this part is internet. So that is where the communication and some processing is done, maybe at the gateways of the local network and on the internet. On the internet, it is only communication, only just forwarding the data, but a little bit of processing can be done at your base station, which is there on the adjacent to the sensors. But the sensors, the things, are the things which basically sense and actuate. Once the sensing is over here, no more sensing is done all through. Right on the right, on this part of it, there is no sensing done. Only sensing is done at the lowest level, that is at the device level, right? So you sense the information, and then you process the information and communicate the data to a local network. From the local network, there is some processing which is done, and then you send the remaining data over the internet. At the back end, as you see, then you see that a variety of data comes in. It can be stored on different remote servers. Data can be stored there, and from there again you can access it, or you can analyze it, right? You can access it from any of your mobile phones or apps on your mobile phone, or a laptop. You can access the data from the servers, and also you can do some analytics. So this is the generic kind of an architecture for the closest I could think of. Then there are two models that I want to introduce just to understand the basics of Internet of Things. Just I'm trying to introduce you. So these are instead of when you compare what is IoT, how is it different from a network, right? How is it different from a TCP/IP network, right? Of course, the concept of packets is still the same, but the kind of the stack that you look at earlier, the stack in TCP/IP model is 5. The OSI IS model, which was what you call a 7-layer, but of course the 7 layers were never implemented. We have the 5-layer TCP, 5-layer or 4-layer. Sometimes the lower 2 layers are said to be combined. The physical layer and the MAC layer is said to be combined. But of course, if you don't consider it that way, you have 5 layers. One is the application layer, the transport layer, the network layer, and the MAC layer, and below that the physical layer, right? Here also you have a different kind of equation, because there is no physical network per se involved, because it's more or less wireless. But of course, from the wired, after it comes to the internet, it again becomes wired. So the whole world is not wireless, right? Wireless is to a certain extent. When you talk about applications on your mobile, it is wireless. When it is sending to its base station, it is wireless, right? The mobile phone connects to a tower, it is wireless. The tower connects to maybe other towers, or from the tower itself, it goes to a cable, and from there it goes as an cable. So from there it becomes wired, or it may go to other towers, and from that base station tower it goes through a cable. From there it is all wired. So even in a institute, when you look at a wireless environment, the final thing is basically wired only. From the core switch or from the main switch, from where the internet is distributed, it is wired. It comes to the switch from where the wireless devices are connected. It is again wired. The wireless device, the access points that we talk about, they are wired, and from there it is wireless. And from then, when you connect your laptop or your mobile phone to the access point, that part is wireless. So as we see, all the edge devices are on the wireless mode, but from there it comes to the networking, and the network layer comprises of both the functionalities here. Okay, the transport layer and the network layer. And then there is, on top of that, there is a layer called service support and application support layer. It's combined. So it supports the application, it supports the services. So that is called the service support and application support layer. It's not the application layer. Application layer is sitting on the top. So if you see a combination between both of these and these things, so they are very much close, right? So you can look at this. We will compare it with a TCP/IP model as well. So let me quickly take you through this, because time is a constraint. I will share the slides, so please don't worry. You can note down, but of course, most of this content is available in most of the standard textbooks. One of the book I would like you to go through is a book by William Stallings. He has written a book on modern networking concepts. It involves cloud, IoT, SDN, NFV. Most of these things he has mentioned in his book. So that's a wonderful treatise. But of course, all these models are publicly available. You just go to Google and type ITUT reference model. You'll get a PDF. Then the next model that I talk about, the IoT World Forum, the IEEE IoT World Forum, IWF model. Both the models are readily available, and you can read them. So these are the 4 layers. The lowest layer is device, then network, application and service support, and then the application layer. And of course, there are 2 management and security capabilities towards the either side, which run through all the layers which I have mentioned, right? So different advantages of each of these. The application layer handles the application point. The service support layer generic support and the specific support for IoT applications and services. So that is what is the second layer. The third layer is the networking layer, consisting of these capabilities, which talk about network capabilities and transport capabilities. Both the layers are handled. Let me give me a minute. Give me 1 minute. So 1 minute. हाँ सर, व्हाट्सएप में लिंक भेज देना, है ना? मेरा एक सेशन चल रहा है, 1:30 बजे भेज दूंगा। हाँ हाँ, मेरा सेशन चल रहा है, तो मैं हाँ कल है वो तो कल है। ठीक है, ठीक कल। Yeah. So networking and transport layer, both the functionalities are part of the network layer here. There are no 2 separate layers like in the case of TCP and IP layer. In the case of the TCP IP called SWET. Both the layers are together. Can somebody handle that, please?
Hello.
Some audio is coming.
Yes, I'll request all the participants to mute their mic kindly. Yes, sir.
Yeah, sure. Thank you. Yeah, request the participants kindly be on mute. It disturbs the others kindly. అలాగే ప్లాన్ చేసుకుంటే నీరు పొందగలరు లైఫ్ లో యొక్క చల్లటి నీడ మరియు తీయటి పండు లాంటి అదనపు ఆదాయ ప్రయోజనాలు. Yeah, thank you. So these networking capabilities and transport capabilities basically are together in one layer. And next layer, as you look at, that involves the device layers, and they are basically into device capabilities, which are direct interaction with the communication network, and or maybe the indirect interaction with the communication network through gateways, ad hoc networks, and of course there is a requirement for sleeping and wake up, because you want to make it energy efficient. So you should have a mechanism where things will go into a sleep mode, and then you can wake them up when you need them. So there must be a mechanism for polling and all that. So that is what is device capabilities. And there are some capabilities which are connected through the wired or wireless network. So there are some interfaces which connect. So you can have Zigbee, Bluetooth, Wi-Fi, variety of protocols, or you can go through the public switching telephony network, or the 2G or 3G networks, or the 4G, that is long-term evolution, or LTE networks. And then you can also have the digital subscriber link, the DSL kind of a network, or a broadband connectivity. That's what we can call it, right? And then the protocol conversion, when protocols at the device layers use different device layer protocols. So the translation or the conversion into two protocols are talking, but two protocols are at a different level. So data coming from this side has to be understood to the other side. So there must be some conversion in between. So that is what can be done at the gateway capabilities, right? So these are device capabilities, and of course the management and security capabilities are also there, right? So let me go to the second model, again trying to introduce you to that. It is called the IEEE World Forum. So if you are looking at publishing literature, publishing some papers, the best conference that I would suggest you is the IEEE World Forum. So IWF stands for IEEE World Forum, the best conference in Internet of Things, right? And then it has a variety of if you're working on security in IoT, if you're working in forensic in IoT, if you're working in the sensor side, if you're working in the routing side, if you're working in the energy efficiency side, all, if you're working on the application side, healthcare, agriculture, and robotics, and variety of things. Internet of robotic things is also an important aspect. So please look at IORT. There are some simulators also for IORT. And in fact, recently I was looking at healthcare. I could get 2 survey papers, which were maybe if you're looking at trying to define where you want to work in IoT. So healthcare things had 2 papers. I think each of the paper had about 400 references. So I think that much of literature is already published. So that's a huge amount of literature to read through and formulate your own problems, right? So please look at that. So these are here there are 7 layers. In the earlier model it was 4 layers. Here there are 7 layers. So the lowest layer is again the devices. The next one is the connectivity, and then there are different layers here called the edge layers, right? So the edge layers are where the data elements are corrected and transformed. Then from here, you would say what is called the data accumulation layer, or the storage layer. And from here, the data is actually is moving till now. Now it stops. So from here, the data is at rest, right? So this is data aggregation here, and you have application layer and the collaboration and other process layers. So 7 layers. So this is called data at rest, and this is data in motion. So in these bottom 4 layers, data is moving, but after this, the data is morely stationary. So data at rest, right? And then they also use the other word from the 4th layer above. It is query based, and below it is event based. All the events are collected and stored. Then the events are queried, or the events are analyzed. So that is what is data at rest and data in motion, or this is non-real time and this is real time. And this is IT and OT. This is operational technology. This is information technology. So all these things are basically data analytics. That's all. Your machine learning algorithms are used, or deep learning algorithms are used on the data which is collected here. But below is basically the operational level, networks, switches, wired, wireless devices, what you call acquisition devices, Raspberry Pis, and other things, right? So they come in, right? So now let me quickly introduce you what are the things in IoT. The things are basically analog to digital conversion is possible. So the devices are called things if they are able to convert into some digital information, right? If anything can generate data, it is a thing. If anything can be queried or controlled over internet, it is a thing. Like a microwave can be controlled, a refrigerator can be controlled, most of your televisions can be controlled. So all these become what is called a thing in the IoT, right? So they can send and receive information. So that is a thing. So then the second level, the second layer is connectivity. It facilitates reliable timely transmission. So it is basically east-west kind of a communication that is at the same layer. If you have a little understanding on software-defined networking, it is called northbound and southbound. Northbound is towards the controller, southbound is to the devices. So all the devices are controlled by the north-south communication, right? But here we talk about the east-west communication layers, which are at the same level. So routers, switches, access points, and all these. So this becomes that. So what are the capabilities here? Switching and routing and translation between protocols and the security and also some network analytics. So that is the second layer, that is connectivity. The third layer is the edge computing, what I was talking about, the north-south communication. So the controller to the lower level of the network. So the packets are coming down and data filtering, aggregation, all these things can be done. This is at the third layer, that is the edge computing layer. Then the data in motion as it is coming, it is converted to storage, right? Till that time it was data generation. Now it is from top above, the data gets stored and data is queried or data is analyzed. So that is what happens. So the data in motion is converted to data at rest. So the transition is there from event based to query based, and a lot of things can be filtered here. A lot of things can be sampled here or compared, or you can do the evaluation, or you can do the aggregation, and a lot of these things can be done. Next level is abstraction. Now, abstraction is where the data is stored in a storage area network or a storage device like this. And from there, you actually try to create schemas of the data or organize the data into better forms. And then you can filter, select, project, and reformat the data to serve your client projects. The client is asking some data, so a lot of nonsense data is there, so you remove it. Only data which is relevant to them, you can copy it and then you can make it. So you can reconcile the data, data format, data shape, semantics, access protocol, security, everything can be done. And lastly, you get to the sixth layer, which is the application layer. The seventh layer is different. The sixth layer is what is called the application layer, reporting, analytics, control, and a lot of these things. Different applications can be developed. But above the applications, there is one more layer which involves people and businesses. So the data is analyzed and make it ready. So people can collaborate and give data and receive data. So not only analyze the data and give results, that is one level, but what you try to do is you can get more data and make your results more effective. And you can share the data with others. So that is what actually happens in the layer number 7, that is collaboration and process. And of course, both the models have different approaches. So if you ask a brief comparison, you can look at both the models are complementary. The ITUT is more with the hardware part of it, or only the lower layers of the IWF model. The first 4 layers is what is the ITUT model concerned with. It's concerned with developing standards for interacting with the devices. But the IWF is how the data is getting used. So the data analytics part is what comes in. Some of you may be interested in data science or big data analytics or predictive analytics. So you will be concerned about the IWF model, which is on the broader issues of developing applications, middleware, and support functions. So hence the IWF model is 7 layered. Right. So these are the things, and they are physical objects. They can have hardware, software, sensors, and network. This is a kind of combination that you have. And basically, they are autonomous in their behavior. They can make some decisions. They can make some processing. They can make some analysis. So a degree of smartness can also be involved. And they are adaptive. They learn. So that is something which is important because they are intelligent devices. And then ensure security, privacy, and trust. So this is another important aspect, right? So if you look at now, what are the components in IoT? If you look at, there are a variety of aspects. So these are listed here. Identification, every device has to be identified. Each device senses some data. It is a sensor, so it reads some data and stores it. It actuates the data or sends it to something else, or it can also, sensors are kind of actuators also, in the sense What I can say is if it is sensor is reading the valve speed, airflow speed, or maybe the water speed, when a certain threshold has reached, I can say you cut down the water, right? So it actuates that cutting down motor, right, which stops the gate or closes the gate of after certain water reaches a certain level, it cuts the rate. So something like maybe if you have think of an air cooler has a certain level, and after a certain level the bulb, the what is called the ball kind of thing lifts up above the water level, it cuts off the water. So that is a manual thing, but in a sensor there is a layer, and if the water level reaches that sensor, the water flow, the tube is cut off, so no more water comes in, so that there is no overflow, right? So that's a kind of an actuator. Then there is a lot of communication which is needed between the sensors. Sometimes they are wired, sometimes and mostly they are wireless. Then a little bit of computation, the processing element is involved. You may process at the local area network also, and you will process at the cloud level also. And then after that, you try to generate a lot of services, right? A lot of data is collected, a lot of data get analyzed, and then you can pass it on. And I'm really surprised. I don't know. Earlier, when the COVID started, most of you were visiting COVID-19 India .org. I think that was the website we were visiting to see all the statistics of how many cases increased, which state is leading. And now I don't think we do it every day. In the earlier days, I used to do it every 1 hour. I used to check what is the state. Now, hardly maybe 10 days or something, I see it once. If somebody asked a query area, what are the latest position now? So then I check, okay, what happened in Rajasthan, what happened in Jaipur, what is happening in India, what is happening in the other countries. So we can try to look at that, right? And then you can also look at some semantics of it. So these are the various components of IoT. So some of the principles that I would like to do it is what is needed. If you're trying to analyze and understand IoT, what you need is the identification, right? First thing is addressing. So every digital device will have a product code or a ubiquitous code, and each of the devices address. Now, every mobile phone has an address, has an IP address, because there's internet running on the mobile phone. If internet is running on the mobile phone, your mobile phone has an IP. And most of the time, when you check your mobile phone IP address, it is IP version 6 based, right? It's not an IP version 4 address, because IP version 4 cannot meet so many, addresses of mobile phones. There's so many mobile phones now. Almost, I would say, the population of the whole world may be around 800 crores or 780 crores now, and all at least 780 crore mobiles are there. All of them may not have a mobile phone, but many people have more than one or two mobile phones. So that makes it equal. So almost the world's population, that many number of mobile phones are there. That many addresses are needed, which a 32-bit address will not suffice, and hence most of the mobile phones have a 128-bit address, which is IP version 6. So if you're looking at Internet of Things, so what you first need to pick up is IP version 6. And the next level, you need to understand a lot of sensors. So temperature sensor, humidity sensor, most of these, in fact, your mobile phone is a very good sensor. A lot of sensing elements are there. How fast you are walking, your SpO2 layer. In fact, I had a mobile Samsung Note 5. The Samsung Note series can give you the SpO2 level, can give you the kind of, what is your heart rate, heartbeat, and all these things could be easily counted. So all I had to place my hand on a sensor which is at the back of the phone, and then it could sense that whole information. And you have sensors in your this thing always, because there's somebody listening to you. Do you realize all your phones, there's somebody listening to you many times? Is somebody listening? If you look at it, you may be surprising, but all through the time somebody is listening, because if I say, "Hey Google," right? So there is an application which is running on my phone. It immediately starts up, right? It says, "Hey Google." I don't know. It's not starting, I think. "Hey Google." There must be some change. Anyway, so there is something which is listening. The Google assistant is listening to you, and then it will respond. So when you are saying "Hey Google" and it responds, so it's listening all through the time. It is listening. So maybe if I can actually try to attack the Google application, so I can actually record all your conversations, right? It's a dangerous thing. So we should actually turn it off, right? And then not allow, because always, at least Google is hearing. Okay, Google may not actually employ some people to listen to your conversations, but it can actually understand and record the conversation. So these are some issues which we can look at. So a variety of sensors we need to understand, wearable sensing devices on the body. Sometimes patients will have to wear those devices and embed those sensors in some situations, or put it inside the body also many times, so that you can send the data and transmit. The actuation is basically some commands can be sent. As I was talking, stop the water flow is a kind of an actuation, this thing. So you can send commands to smart device, start, stop, or increase the speed or decrease the speed, something like that. So the decisions are taken on the edge or cloud and passed on to the devices to act upon. So that is something which can be a water level sensor, or smart electric motor can be the things. The next level is what is called communication is required. So obviously you need to look at 5G, right? So first thing is IP version 6, kind of an addressing the whole methodology involved there. The second thing that I would like to talk about is 5G networks. So please understand what is the difference between 3G, 4G, and 5G. What is the bandwidth? What is the speed at which things can operate, and what are the requirements of 5G? So as we implement 5G and using IP version 6 on new protocols like Zigbee and RPL and all, so that's going to be the whole scenario that we have to consider. So it connects intelligent devices and facilitates machine-to-machine communication. The communication networks are these, and then there are some short-range requirements like Bluetooth, 6LoWPAN, and Wi-Fi, and not NGC. It must be NFC, right? So the near-field communication. Near-field communication is the technology which is built in. Maybe if you have a credit card which has the wave symbol on that, you can take it to a petrol bunk and swipe it on the credit card machine. You don't have to insert into that, or you don't have to swipe it like this. You just place it on that machine. It detects. The machine detects. The machine senses the near field communication, but it must be NFC enabled, right? So 6LoWPAN, of course, is a wireless, low-powered, wireless personal area network for IP version 6. The 6 stands for IP version 6, right? Then you have WiMAX, Z-Wave, and Zigbee. So all these things are all needed at the lower level, medium range and long range, and short range. Cellular is long range. Short range is small range. So Wi-Fi is maybe 20 feet or 20 meters, something like that, right? So internet is the primary medium to connect to the cloud, and moving to the next generation IoT, you need what is called 5G. So the protocols that are used are IP version 6, IP6, 6LoWPAN. Transport layer, you use obviously TCP and UDP. But at the application layer, new protocols have come called COAP and MQTT. Maybe in the next session, I will share about COAP and MQTT. Of course, I cannot go deep into it because each of them is a protocol. It has a request for comments, maybe a PDF of some 50, 60 pages. So you can read through that, right? So these are some of the common protocols, or the most common that I would like to leave with you. One is COAP, one is MQTT, and then one is Z-Wave, one is Zigbee, the other one is Bluetooth, and then the 6LoWPAN. So these are the protocols which are very much needed, and you can try to look at, right? So comparison between TCP/IP protocol suite and the IoT protocol suite, if you look at. So these are the lower level, the data link layer and the physical layer. So you have 802.15.4, which is the primary low power protocol that we talk about. So the wireless networks, so 802.11 AC, 11A, B, G, N were the earlier wireless protocols. But this is a low power wireless 802.15.4. So you can look at the 802 series. 802 series has a variety of protocols, and you must see the difference between what is 802.11, 12, 13, 14, 15, and so on. And what are the parts on 15, 15.1, 15.2, 15.3, now 15.4. But what was 802.11? 11 had again 11A, 11B, 11G, 11N, 11AC, and so on. So a variety of protocols. In the Bluetooth 4.0 now 5.0, 5.1 has also come. So you can read the later protocols which are there. Wi-Fi, the near field communication. Above that, there is a layer which comes in between the network layer and the data link layer. It is called the 6LoWPAN, right? Low power wireless personal area network protocol, which actually bridges the layer between the data link layer and the network layer. The routing protocol, IP version 6 or 4 can also be used, or an RPL can be used. It's called the routing protocol. Some of the BTech students and MTech students worked on a routing protocol, and we had come up with a cross-layer attack. We could simulate. I think we were the first. We claimed to be the first, and then of course nobody refuted it. So we were the first to create or simulate a routing protocol. Here at this time, I will encourage you. Maybe you should look at what simulators called NS3 you can use, or obviously you can do it on MATLAB. Or one of the protocol simulator that I appreciated was NetSim. Of course, we got a trial version at that time. We are going to buy NetSim now. NetSim is another good protocol simulator as far as the IoT is concerned. These days, you have the 5G network, the SD, and most of these protocols are implemented on NetSim, and then you get a lot of advantage. At the transport layer, only UDP. Then there's another layer which is a secure transport layer security, which falls between transport layer and application layer. And then the COAP MQTT protocols are the other protocols which are there. The COAP stands for Constant Access Protocol, and MQTT stands for Message Queuing, Telemetry, and Transport Protocol. So we will look at that, right? So a slightly different version of looking at it. So you have these 5 layers, which are TCP/IP protocol suite, but at the lower layer is what you are looking at, right? So 6LoWPAN comes here, but the ZigBee moves on starting from a network layer and the transport layer and goes up to the application layer, and is able to successfully or very finely interact with the IEEE 802.15.4. So there is a very close relationship between these two, and then it compasses through the 3 layers: the network layer, the transport layer, and the application layer. All those layers is where ZigBee can yield. So the TCP and the TCP UDP runs at the TCP layer. The network layer has the routing protocol. The in between there is a 6LoWPAN. So if you want to construct a layer level architecture, so you need to have one of these low level protocols. On top of that, you have the 6LoWPAN. On top of this, the RPL. And on top of that is the TCP, and then some applications which are there on top. So these are the so by and large, the major protocols that are involved, or the stack that is there, is from the bottom to the top. So 802.15.4, 6LoWPAN, RPL, COAP, and lastly MQTT, or COAP and MQTT are adjacent to each other, right? So these are some of the communication features. You need the address modes and high reliability and path selection, mobility. Let me skip some part. I'll share you the devices, share you the slides so you can go in detail. The computation, the part that is a little higher than the device, where the processing can be done, is some of these devices which are called smart things or Arduino, small chips, small printed circuit boards with the small chips and Wi-Fi, and maybe you can have an USB kind of thing and Wi-Fi devices and a dongle kind of thing, which is basically you can use it as a Wi-Fi device now. So the prominent things are Arduino Uno, Raspberry Pi, Galileo, BeagleBone Black is another device, and then there are smartphones which can be used, because smartphone has many sensor applications. So you can have another application which will read all the applications data which are available on the smartphone, and then you can do that. The data is processed both locally and on cloud. So these are small chips, and maybe the cost will be around 3,000 to 5,000 rupees as we look at. So if you are going to develop an application, you will need to buy at least 5 or 6 of them and place them in the open network, and then connect them through Wi-Fi, and then try to generate an application, right? So that is how it proceeds as the computation there. Then if you want to run the programs, so operating system, you will have Contiki OS. Contiki, it runs, it's a kind of a tool which you can use. Then the Tiny OS, the Light OS, the real-time IoT, so RIoT, and then Android. And of course, cloud, where the data can be stored. So Nimbits or Hadoop or AWS IoT, IBM Watson, Cisco IoT, it goes and stores there. So the computation part of it. Then the services, so you can do the shipping, you have the information aggregation, which is available in smart grid, collaboration aware in a smart home, ubiquitous, pervasive kind of thing in a smart home, and smart retail, smart building. I'll show you some of the examples, some of the applications that you can look at. So these are the applications that we tend to remember here. The transportation and logistics, healthcare, smart environments, personal and social IoT is a very important IoT that you can look at. Futuristic IoT, robotaxi, city information model, advanced game rooms. But of course, basically transportation logistics. So assisted driving, the maps are given, and you are able to you can able to traverse the whole city. The first time I was assumed, I was shocked when one of my friend had a smartphone and he showed me the map of Delhi and we were traveling, and he also told me, "Arey, I also don't know all the roads in Delhi, and this application helps me." Oh, I said, "Oh, Google Maps." Oh, we didn't know that, right? So that was the first time I was seeing Google Maps, and it is showing the distance, it is showing the kind of what is called it was showing if there is a jam somewhere in the red color, and then if it's orange if it is slightly busy, or green or blue if it is free. So these kind of things really assisted driving, mobile ticketing, environment monitoring, augmented maps, everything can be easily obtained. So Google Earth is an augmented map as you look at, right? So the healthcare, the tracking, data collection, sensing, smart environments in homes and offices, and a variety of things, right? So uh, and then of course the container safe irrigation and variety of applications that are seen on the containers. And then you have the residential meters, smart street lights, pipeline detection, and traffic control, surveillance cameras, and all these. And then of course smart manufacturing, flow optimization, real time inventory, everything can be tracked. The whole thing, whole process can be tracked. If you're looking at the similar thing in manufacturing, in agriculture, right? That whole thing is actually manufactured or controlled. The whole agriculture process can be totally controlled. So all everything, every timing, and every seed and everything can be counted, right? So in that sense, if you look at so a lot of analytics can be gathered and ensured that things are made very clear. So a lot of things are available, right? At the same time, retail, the barcode in retail and electronic tags can be there. Data management, pest management, urban planning. So that's where agriculture can come. And of course, when the pharmaceuticals, you are able to track a medicine, you are able to track a strip of medicine to the person who made that in the pharmacy lab, and the one who sold the medicine, and the one who prescribed the medicine, and the one who consumed medicine. Everybody is linked. Okay, so now if a medicine damages a person, you can actually catch hold of who made the mistake, right? So that is something which can be done. And at the same time, food processing. So a lot of these things about a number of calories and everything can be checked, and then quality of food and all. School administration, and as you're live seeing now, this is a mechanism which is being generated because of the Internet of Things. So what is now happening? So, what are the challenges? The challenges are scalability. The challenges are security. The challenges are privacy. The challenges are heterogeneity, technological standards, software complexity, and costly infrastructure. So, if you are able to scale to the demand that is there, so that is something which is needed. If you can keep the devices secure, if you can see the keep the communications secure, if you can keep the information private, and handle a variety of devices, heterogeneous, and the networks are also heterogeneous. So we need to understand that. Then a lot of technology standards, the complexity of the software that is involved, and it's just a costly infrastructure anyway. So of course, security issues are there, variety of things. So let me just look through, and there's a security model which goes through all the 7 layers, right? That's what they talked about. So different advantages and disadvantages of the models. So I'll stop here for the first of the lecture, which I should have completed in the morning itself. So we'll take some questions, and if there we'll take a break also, small break, and then we will commence again. So if you have any questions, you can please ask.
I'll request the participants to either unmute themselves while asking the question, or they can also write in the chat box.
Sir, as far as research is concerned, what are the things we need to concentrate on? Please explain.
Yeah, it depends on which spectrum that you are concentrating. If you are concentrating on, let us say, on the application side, then you need to select the kind of application that you would like to focus on, right? That's one thing. And then if you are looking at the protocol layer, because computer networks is a major research area, and IoT is very much a part of it. So that is very interesting. So that is another thing. Then the energy efficiency becomes a very important thing. So like that, when you keep selecting a variety of options do come in, right? So what I'm trying to do for you is just trying to get you the call for this thing, the WFIoT call for papers, just so that you can have a look at it. There are variety of things which are asked at this time, right? So and
Okay, sir.
you can start from that point, and then you can look at where do we proceed, and where do we go. So let me just see if I can get you that. Just give me a minute.
Okay, sir. One
Yeah.
more thing. See, suppose we anyway interconnect things in the sense, for example, in the case of COVID and all, so we are not able to trace from where it is that origin and all. We are not able to trace. So,
Okay.
moment you connect that is actually from that research lab. Then how exactly things are happening, that we are able to track that thing. That will be of very good research, right? Are you
Yeah.
getting my point?
Yes, but
Yeah,
couple of
that type of one thing, because all are connected, so that things are happening. Because I mean, hospital wise, then patient, then drugs like that and all. Anyway, we have some sort of interconnectivity. So similarly, so the research is happening in such an area, so we should be able to track such people. So
yeah.
such type of one research we are planning in the sense how we can proceed.
Yeah, I understand. But if you really
Okay.
look at, if you let me share this with you, what I'm doing here. Right? So let me just share this.
Professor, good afternoon.
Yes, sir.
I have a question about environmental issues.
Yes,
What
sir.
is your idea? Because 5G, you are going for 5G also.
Yes, sir.
Already we've seen that the birds are affected more than the human beings. In advance, if we go for 5G, human beings also may be affected. People are just in that note. Because if everywhere IoT, human beings become lazy for door opening also. If everything is happening, then very agriculture field also very getting. At present, the agricultural farmers are more strong. They also become like us. No, don't mistake me. Please kindly answer for this question. Thank you.
Yeah, definitely the microwave transmissions and all are this thing. But at the same time, there are regulatory bodies which actually will control, right? Whenever there are people are placing the what do you call mobile stations, right? Or the wireless, what do you call the base
3G,
stations
2G we have. Yeah.
of the mobile phones, right? Like Idea or
Yeah.
Vodafone
2G,
or
3G we
Airtel.
have the regulation.
So there are regulations. So similarly, when 5G, when they are trying to develop the things, and then actual implementation does come in, so all these aspects will be handled, right, and will be taken care of. So, but at the same time, there is a cost that is involved, right? Definitely, we all know we are keeping our mobile phones with us all through the day, keeping near our head all through the day,
Right.
keeping near our heart all through the day. We know, and there is a certain amount of risk. But yeah, compared to the comfort that it is providing, these efforts are there. Now, similarly relating to agriculture, if the farmers are able to produce better food, and if the farmers are able to produce more output, and are able to care for their produce, right, and they're able to do something really very good, then I think that's a wonderful contribution. Of course, it will definitely make the agriculture thing a little costly, but value for money is what I would like to look at. Right? When a big land has to be cultivated, if the government can provide the infrastructure, of course, it's a policy matter again. So in those cases, if that is done, just imagine the impact of the power which you can yield, and you can take care on a bigger scale. As of now, we are not understanding the scale because we are thinking of a very poor farmer. But just imagine a farming society which actually sets up a lot of things for the farmers and helps them. It is like a metro in Delhi. If metro in Delhi was the money was not invested, now if you ask, is the Delhi metro good or bad for Delhi? It has reduced so much of what do you say pollution. Even then, Delhi is polluted. Just imagine what the life would have been if the metro was not there. But metro, is it now income generating? Yes, Delhi's metro is so rich now. It has so much of money. But initially, the money that pumped in was needed. So in a similar sense, whenever we are looking at a new technology, we need to pump in that money and the resources. And there is a risk that is always involved of loss of jobs or loss of health and all. But at the same time, there are some advantages which the technology is going to give in. So there is obviously a trade-off in between both of these that I would like to say. So let me share this 2019 World Forum on IoT. So these are the presentation topics as you look at. So these are the various areas where you are. And but then again in detail, if you look at it, there are I think somewhere the detailed call for papers is there. So each of these areas are explained in detail. So I think I did. This is a short World Forum on IoT call for papers. I think I'll try to get the complete one. Let me check it. So if you look at that, a complete list of topics is there. Maybe you can go through that and look for. Okay, so
Okay.
that should be there. Yeah. Yeah. The next question we can take it. While I'll keep.
Sir, add on to this. Sir, the primary concern is the quality. So whatever we produce in India, in Indian context, the quality is the concern. Second point of is what are the ecosystems do we adopt? See, if we make a product, any product, whether it is a academic per se or the commercial per se, the concern is the ecosystem. So according to you, sir, what ecosystem would you like to adopt it so that we can make a feasible product and it will be sustainable? It will be sustainable with respect to quantity as well as with respect to quality.
With respect to quantity and quality, ecosystem in the sense, see, as I told you, IoT is.
You already gave the example of Delhi Metro. So Delhi Metro started when they build a ecosystem. Without ecosystems, they are not able to think of to make the metro in phase 1 or phase 2 or phase 3. Similarly, if we plan for doing IoT or implementing IoT in various aspects, whether it is in agriculture, manufacturing, or so many areas you have pointed out. So according to you, what ecosystems would you like to adopt it so that the youngsters come forward and they can adopt it and they can make it at low cost device, at low cost solutions for the society?
Right. So what is actually there is most of the things are there. The sensors are there. The 5G network is coming up. Obviously, the 5G network will be implemented in a year or two in India. By 2020, it was supposed to come, but because of the COVID situation and all, it slightly got delayed. 4G is now fully available in most of the country, and 5G will come up maybe in 2 years. That's what I would like to put it. IP version 6 addressing has started. Slowly, we will have to move all the devices to IP version 6, which will happen in another 2-3 years. That's what I would like to put it. So in the next 2-3 years, all these things are coming together. And obviously, Internet of Things, Cloud of Things, Internet of Robotic Things, Internet of Healthcare, everything, Internet of Vehicular Things. Now, you name any technology, any application, it is going to be connected through sensors, through data collection points, and this. So the job opportunities or the research opportunities for youngsters is basically in trying to bring all these things together. You need to understand IP version 6, you need to understand 6LoWPAN, you need to understand sensors, you need to understand data analytics, you need to understand applications, what kind of data needs to be collected. So if this whole ecosystem can be created, I think that is what. See, data science is going to flourish and only when data is collected. And who is going to collect the data? The Internet of Things devices are going to collect the data. So a clear ecosystem is already created. So, and then the network is being set up which connects this data. So wired and wireless has proliferated. Mobile phones have facilitated connecting anywhere. Now, anybody sitting in any small village is able to connect to a lecture like this and listen because he's able to access internet on his mobile phone, right? And then he's able to connect to some applications like WebEx or Zoom or Google Meet, and he's able to listen to the lectures, or at least he's able to listen to the content, at least in that sense of the lecture. So that way the ecosystem is ready. The challenge is the programming that is involved, the protocols that are involved, and the applications that have to be developed. So these are the challenges. I think that is where the scope looks like. So let me show you this is a paper that you can download. So World Forum of, are you able to see these slides?
Yes, sir. Yes.
PDF, horizontal IoT enabling technologies. Are you able to see this?
Yes, sir. Yes, sir.
Yeah, the sensors and actuators. Okay, power and energy in IoT, connectivity for IoT, Each is a research area. Computing platforms for IoT, okay, and then data acquisition, storage, and management. This is where the semantic part comes in. Data storage, data analytics comes in. Application-oriented technologies, security and privacy, IoT system interfaces, design and testing. Then a whole lot in applications and services. IoT applications, IoT services, IoT multimedia and societal impact, IoT experimental results. Or these are the kind of topics that are involved. So if you go through the call for papers, each bullet point is a research area, right? So you can try to actually look at how to do it. Each of them is a challenge in India. India,
The problem in India is the end-to-end delivery with respect to the farmers. That is a major concern, because I have talked to many industry people. I have been in touch with them. So the problem, because why they are not flourishing this technology in the farming area, because of end-to-end delivery. Because farmer you cannot.
Yeah, I agree to a certain extent. So that is where our research comes in, where we have a societal impact. Recently, I was attending a conference on RAISE, called RAISE, organized by Government of India, Responsible AI for Social Empowerment. So similarly, a responsible IoT for social empowerment is what is the challenge for this time. So that's what I would like to tell. So we have to understand technology, and we have to make it as close as possible to the society as possible. If the research is not having a societal impact, we are only publishing for our sake. We are not actually impacting our country. So our research must have a social impact, or it must empower the society. So I think social IoT also goes in that lines. But of course, it deals with social networks and all that. But at the same time, if I am trying to work for some solutions which are going to make my life better, make my society better, IoT is definitely an enabling factor.
I think Dr. Pilli sir, you can take some more questions after the second session.
Okay, sir. We'll take a break for some time.
So when we can meet?
5 minutes at least. Give me some time.
3:30 we can meet.
Yeah. Three. Okay. 3:30 will be.
We'll meet at 3:30 p.m.
Yeah. Others can also have a break, just maybe have a snack or have a tea or something, and then
Yes, sir.
we'll
Yes,
have
sir.
1 hour lecture from there.
Yes, sir. We'll meet at 3:30 p.m.
Sure. Yeah, you can be online. I'll just take a break.